Hello students, in this video I'm going to demonstrate how to solve a system by the Gaussian Elimination Method. The first thing we have to do is we have to take these three equations and put them into a matrix form. So we take the coefficient of each term. So this matrix, we have a X column, a Y column, and a Z column. And this is our solution column. And our goal is to create a matrix that has ones down the diagonal. So that we can find the Z value, the Y value, and the X value. So the first thing we have to do is we have to get the first term of the second row to be 0. So actually I take that back. The first thing we have to do is we have to get the first term of the first column to be a 1. Well, I can simply divide each term by 4 so that the first term is a 1. So I can, in essence, say 1/4 times row 1 will give me a new row 1. So if I was to divide each of these by 4 or multiply by 1/4, I'd have 1, 1, 3, 2. And then all of the other ones come down just like they are. Now that I've got that to be a 1, my next step is to now make this a 0. So I'm going to take -4 times row 1, add it to row 2 to get new row 2. So if I was to multiply row 1 by -4, I'd have -4, -4, -12, -8. And I'm going to add that to row 2. So my new row 2 is going to be a 0, -1, -3, -2. Now I want to make my first term of row 3 0. So I would have to multiply row 1 by a -2. -2 times row 1 plus row 3 to give me a new row 3. So if I was to multiply the row 1 by -2, I'd have -2, -2, -6, -4, and I'm going to add that to row 3. So that will give me a 0, a 4, let's see, that's going to be 15, and that's going to give me a 5. Now I have to rewrite my matrix all over again. 1, 1, 3, 2. My new value, 0, -1, -3, -2. And then my new row 3, 0, 4, 15, 5. Now that I've got zeros on the lower 2, I have to make my middle value a +1. Row 2, second term, a +1. So if I was to simply multiply -1 times row 2 to give me a new row 2, I'm going to have 1, 1, 3, 2, 0, 1, 3, 2, 0, 4, 15, and I can't read my own writing, so that was a 5. Now I have to get this 4 to be a 0. So if I multiply row 2 by -4 and add it to row 3, I'll obtain a new row 3. So that would be 0, -4, -12, -8, 0, 4, 15, 5. I'm going to add those together. 0, 0, 3, negative 3. So now my matrix is going to be 1, 1, 3, 2, 0, 1, 3, 2, 0, 0, 3, negative 3. I'm almost there, and now I have to have this to be a 1. So now I'm going to say 1/3 times row 3 plus, so just to give me new row 3. 1, 1, 3, 2, 0, 1, 3, 2, 0, 0, 1, negative 1. So now I have x, y, and z, and my z value is going to equal negative 1. Now I have to plug that back into my line right above it. I can change this just like I changed my original equations into matrix form. I can change my matrix form back into polynomials. So if I want to rewrite this as a polynomial, it would be 0x, which is 0, plus 1y plus 3z equals 2. Well, I know that z equals negative 1. So I'm going to plug in negative 1 for my z. So I have y plus 3 times negative 1, which would be a negative 3, equals 2. Solve for my y, so I'm going to add 3 to both sides. Y equals 5. Now my very top equation, if I put that back into a polynomial, I'd have x plus y plus 3z equals 2. Well, I know my value of z. I know my value of y. I'm going to plug those back in so I can solve for x. So x plus 5 plus 3 times negative 1, which is a negative 3, equals 2. So then I have x plus 2 equals 2. Subtract 2 from both sides, and x equals 0. Now that I have all three values, I need to write those as an ordered pair. X, Y, Z, well, my x value was 0, so I put 0. My y value was 5, so I put 5. And my z value was negative 1, so I put negative 1. And this is the solution to the system. I put fancy braces around it. It's a solution set. So the ordered pair 0, 5, negative 1 is the solution to the system by using the Gauss elimination method. I hope this was helpful. Have a great day.